Yeah, we want to talk today about how we can run VM workloads side by side with container workloads. I'm Sebastian Scheele, one of the two co-founders of Loodse, and with me on stage is David.
Principal engineer at Red Hat, one of the core contributors to the KubeVirt project. So, want me to take it?
Yeah, you will start.
All right. So, I'm going to just kind of give an overview of the KubeVirt project and what we're doing here. So, Kubernetes is a container platform. And KubeVirt is a virtualization extension for Kubernetes that allows us to run virtual machine workloads side by side with container workloads. And from a really high level, what I'm talking about here is giving Kubernetes the same kind of ability to do the use cases that you might use something like OpenStack for. Can we get that feedback maybe backed off a little?
It's working.
All right. So that kind of begs the question to me, why? Why would we do this? We already have on-premise solutions like OpenStack and KubeVirt, and we have the public cloud. We know how to manage virtual machines there in AWS and GCE, and we even have things like VMware. So we solved this problem of VM management 100 times in 100 different ways. Why are we doing it yet again with KubeVirt? So a couple of reasons. First one, infrastructure convergence. So if you have legacy virtual machines right now, maybe they're not even legacy virtual machines. Maybe you have to develop some of your applications in virtual machines, but you also want to do development in containers as well. Your system probably looks like this. You're going to have two stacks. One for your virtual machine management, maybe that's running OpenStack, for example, and a separate one for your container workload management, and that's going to be Kubernetes. So with two stacks, that means you're having to duplicate everything. So you're duplicating your logging, your metrics, your monitoring. You have two schedulers. You're going to have two networks, two storage providers, all of this. And that operational complexity comes at a cost. The more complex an operation is, the more costly it is to operate. So with KubeVirt, we're converging these stacks. Now you can run virtual machines and container workloads using Kubernetes. And we're reusing all the things Kubernetes gives us. So the same logging, same metrics, monitoring, the same scheduler, the same storage and network that you're using for containers, you can now use for virtual machines. We're even extending this to things like RBAC. So you create a role that gives a user the ability to schedule a pod. You can also give the user permissions to create virtual machines. So we're tying into all the things that Kubernetes gives us today. So infrastructure convergence, one stack. Second reason for KubeVirt, workflow convergence. So back in, I think it was like 2014 or something, when I first heard about Kubernetes, I didn't quite get it. I was working on another cluster manager actually at the time, and I saw Kubernetes as just another way to do the same thing that all the other things did. And there was a few things I was missing there. And one key part I was missing was the power of this declarative API. So in Kubernetes, you declare the state you want, and Kubernetes converges on that state. So for example, if you have a deployment, and you say you want 10 replicas of that deployment, then Kubernetes converges on that. It's going to give you 10 pods. If a node goes down that's running one of those pods, KubeVirt reconverges on that state, and it's going to spin up that 10th pod somewhere else for you. We're allowing virtual machines to be managed using the same declarative pattern. In addition to that, we're using all the same tooling that you already use for container workloads to manage virtual machines. So if you're using kubectl or kubecontrol or kubectl, I don't know, whatever you call it, the command line tool to create a pod, like we have on the left-hand side, you see that you're just creating the pod by defining the manifest and posting it to the cluster. That's the same way you manage your virtual machines. So on the right-hand side, you can see an example of us posting a virtual machine manifest to the cluster. And just kind of looking, I don't have the whole manifest there, but you can see it looks Kubernetes-like. It looks really familiar. You're going to have a metadata section. You're going to have a spec and a status. The kind is a virtual machine instance. That's our API that we're registering as a custom resource definition. The things that differ are the things that are in the spec. So we have virtual machine specific values in there. So workflow convergence, we're allowing virtual machines to be managed with the same declarative API that you're using for containers, and you're using the same tooling. So one last thing before I do a demo, I want to talk about the simplicity of our install process. KubeVirt, it just drops into any existing Kubernetes cluster, and it's that simple. You don't have to do any sort of node level configuration. There's no changing of runtimes or anything like that. It's just going to work. So it's as simple as going to our GitHub page. You can find our releases. You can take one of those manifests in the releases, and you can just post it to your cluster. So kubectl create -f, and I have a URL there, and that's one of our release manifests. That's going to pull in all of our APIs, custom resource definitions, all of our components that involve the virtual machine launch flow. It's going to install that for you, and you didn't have to think about any of that. At that point, you can just start using our API, start posting virtual machine specs, and virtual machines come up. It's that easy. The reason it's that simple is a key architecture decision that we made early on, and that was we're going to run virtual machines inside of pods. So that's how we reuse the scheduler, reuse everything that Kubernetes gives us. We're just running a virtual machine process inside of a pod. So when we post a virtual machine instance spec, that's our manifest, that's our API to the cluster, we have a controller behind the scenes that observes the creation of that object, and in response to that is generating a pod for that virtual machine instance process to live in. So if in your virtual machine instance manifest you said you want a 4-core machine with 10 gigabytes of memory and a persistent volume claim with a virtual machine disk on it, then when our controller generates the pod for that virtual machine to live in, it's going to have all those resources assigned to it. When the pod starts up, there's a component inside the pod that manages mapping all of those resources that have been attached to the pod to the virtual machine process that we're starting inside of the pod. So the end result here is we kind of have a virtual machine process in the pod that kind of assumes the role of the pod. And to kind of drive that home, with our default networking, if you ping the pod's IP address, you're actually getting a response from the virtual machine guest. So the guest owns that network device that CNI created for it. All right, so I'm gonna do a quick demo real quick. This demo has been recorded, so if you're interested in looking at it again, take a picture of that. You can play it back for yourself, inspect what I did, and you can even try it out for yourself if you want. What I'm going to do is I'm going to show you an example of creating a virtual machine, and then I'm going to quickly live migrate that virtual machine. So that's a new feature we have. You can live migrate a workload from one node to another. All right, so to start with, we have 2 nodes, because you have to have 2 nodes to do a migration. I'm going to show the virtual machine instance manifest real quick, show you what's going on there. This is a full manifest. I guess it cut off a little bit at the top. That's okay. In the specs, the only thing that's worth pointing out here is the type of disk that we defined here. It's a cool feature we have that lets you actually put your disk inside a container image, and you actually can run the disk from a container image. So we're allowing you to run virtual machines and distribute the virtual machine images in container images, which is kind of a neat thing. All right, so I'm going to post this manifest to the cluster. We've created the virtual machine, called it VMI migratable. We'll take a look real quick at it. All right, so we see it scheduling. That means the pod's been created. So let's take a look at the pod. All right, so that's the virtual machine instance pod. That's where the virtual machine process lives. We now look at the VMI object. We can see a few things. We see in the events section here, we can track the state of the virtual machine instance as it started. So we see that it was successfully created. That means the pod was generated, and now the virtual machine process inside that pod has started. So for fun, I'm going to log into the console. We have a convenience tool called virtctl that lets you do some extended functionality. You don't need it to manage your virtual machines, but it does allow you to log into the console, which is nice. So now I'm inside the virtual machine. And what I'm going to do here is I'm launching a simple process here that's it's just a loop echoing some output. So what I want to do now is I want to migrate that virtual machine to another node, and I want to log back into the console after I've migrated and show you that that counter is still ticking. It represents a process running inside the virtual machine, and we know that it wasn't interrupted. So to migrate a virtual machine, we have a migration object that needs to be posted to the cluster that declares that you want this virtual machine to move from one node to another. So if you look at the migration spec, it's really simple. This one's really simple. All I said is the virtual machine name that I want to migrate is VMI migratable, and we're just telling it by posting this object that we want it to move somewhere other than where it is now. So we'll post this manifest to the cluster. The job's been created. If we look at the pods here, we see that another pod has been generated on a different node, and that's the target for this. And we do it describe on our VMI again, we see lots more events. So we're tracking the migration. We can see when the target was prepared. This happened really fast because it's a really small virtual machine that I'm running. We can tell when it started migrating, when it finished migrating, when the virtual machine process is up and running in the target pod. So if I look at the pods again real quick, I see that the source pod that it originated in is completed. And if I log back into the console, workload is still running. All right, I want to hand it off to Sebastian. I'm interested in your use cases for KubeVirt and why you're interested in this talk, so find me afterwards.
Cool, thanks. Yeah, and I want to talk a little bit how we are using KubeVirt to run also Kubernetes cluster on top of a Kubernetes cluster. So from Loodse, we built Kubernetes, which is a platform to run Kubernetes cluster anywhere. So we can run on cloud provider, on-premise. And what we saw quite often, or see quite often, especially if you're in the on-prem environment, customer have this huge bare metal machines, but you want to have not like 10 500 gigabyte machine in one cluster, because then you have 5 terabyte of memory in the cluster, and this is not working. Your developer wants to have a small cluster, a development cluster. The next developer wants to have a small cluster. So what we saw a lot of times is like customers are using OpenStack, VMware, or other virtualization solution to only for partitioning the machines into smaller chunks. And so the main challenge with this is you must manage two different platforms. You need to manage like OpenStack, and on top of this, you need to manage Kubernetes. And so when KubeVirt was announced, we were looking into it and say, interesting concept. Because we were already internally also thinking about, can't we run a KVM inside of a pod and let that VM join one of our clusters? So it was more or less similar ideas, and we were saying, cool, let's see where this is going, and potentially we can integrate this for some use cases to streamline and to make the API at our customers and the usability much more easier, so that we really have the possibility to run everything with Kubernetes. The only tool what you need is kubecontrol, and you don't need different tooling to manage this. One team can managing all. And the other big side effect of this is I think it's unrealistically in the next years to get everything inside of a container. You still have like virtualization workloads, but then you have, like David mentioned, the unified platform. You can run your Kubernetes cluster, you can run your containers inside, and you can also side by side your VM workloads. So we are quite actively in the cluster API. I'm not sure who is familiar with the cluster API. Okay, only a few. I will give you a rough overview. So the idea of the cluster API is the zig of Kubernetes to create a declarative API to spinning up Kubernetes cluster. And one part of this is the machine API. And I will show you how we integrated KubeVirt into the machine API. So the main concept of the machine API is to make really machines natively available inside of Kubernetes so that you can do kubecontrol create machines, or even like kubecontrol create machine deployment. And Kubernetes will manage and generate all of your machines. And this kubecontrol create machines should run everywhere the same. It doesn't matter if you're on the cloud, on AWS, on Google, or if you're on-prem, with KubeVirt or VMware, or even when you're using tools like Mars, you have an API for your bare metal machines. You could also do this integration with your bare metal machines directly. So the main component here is a machine. It's a declarative point to describe how your machine should be configured, like what kubelet version you want to have, how to provision a new node. And then what we have is a machine controller who watches on this object, on this machine objects. So when you create a new machine, the machine controller will detect this, and then will do the necessary stuff, and then at the end create the VM, in this case on KubeVirt, or like on your cloud provider. And afterwards, when you delete the machine, also delete the VM again. How did we implement this? So our machine controller is open source. It's when you check on the cluster API repository, you find a link to it, or you can find it also at the end of our presentation. There's a link to it. And mainly, it has 6 methods we must implement. The 2 main methods are create and delete. So we must create a custom resource definition for KubeVirt, and then KubeVirt is picking it up, and we must delete it, and some other smaller functions to do this. But because this is so generic, it took us like to having a first POC running with KubeVirt 3 days of development, and then we already could run Kubernetes cluster with Kubernetes on top of bare metal machines. And this is what I want to show you now. So in the back end, I spin up the master with our tool Kubernetes. So the master is somewhere running, and then I'm running this machine controller. And now this is checking all the time if there are any changes, and then executes this changes. And on the one side, I have my we call it user cluster, where the developer want to deploy some workload on it. So it's a normal Kubernetes cluster. In this case, we use Flannel as an overlay. And I have my bare metal cluster, where everything should run on top of it. And so what I already did here, as I said, I created already a machine deployment. So we have a machine deployment with 2 replicas, and this is then mapped to a machine set. And the provider you see already is KubeVirt. So similar like deployments and pods in Kubernetes, we now have a machine set, so that we can also do rolling upgrades of the machine. And then based on the machine set, we generate the machines. And then what we technically do is like we place the custom resources for the kubelet controller, for the KubeVirt controller, and the KubeVirt controller is picking this up and spinning up the machine. So when we're looking here, that's now the bare metal cluster. Here you see KubeVirt is running with their API and their controllers, and you see also 2 instances launched for our worker nodes. So when we now do kubeget nodes, you see the master, but we have 2 worker nodes running here. And what we also can now add, we can create a new machine deployment. So now when we do kube get machines, we will see now there are 2 new machines created. Potentially we see it still in the logs. Yeah, you see here it's processing the entries which is created, and now when we check on the bare metal cluster, we have 4 virtual machines running. It now takes a little bit time to start this up and that they are ready to join. It takes now 4 or 5 minutes so that they're ready to join. But then all of this is running, and the developers can use the small cluster for the development purposes. And we could easily do we could easily also scale the replicas, so scale it up, scale it down, change also, where do we have it? Here you see the configuration, you see cloud provider is KubeVirt, and then you have some specification for it. You see the amount of memory, CPU, and you see the kubelet version. So when we now want to run and upgrade our cluster, we only would change the kubelet version, and then the machine deployment will generate a new machine set and will generate new machines. And so the old VMs will be terminated, and KubeVirt will create new machines out of this. Let's see if they're already there. Yeah, still in process. If you're interested in the implementation is quite easy. It's like, in total, it was 350 lines of code to integrate this. It's currently POC, but you can, of course, try this out, and it's running. You can run this on a Minikube cluster and connect this with your bare metal cluster. And now we really have the possibility to manage a lot of smaller clusters on top of these big bare metal machines, and can provide developers like 1 or 2 node Kubernetes cluster instead of trying only multi-tenancy with namespaces. So now one developer can run already on 1.11. The next developer who want to use already 1.12 or 13 can already deploy this, and they can individually decide, okay, when it's the best time to upgrade. And as an operation, from an operation perspective, I only need kube control and perhaps virt control. But even this, so like when I'm currently working with like cloud provider, I barely use their CLI, because with this you can already use kube control to manage everything, because when a VM dies, we don't care, it's automatically restarting a new one. So I'm not really looking into what's happening in the VM. As long as the VM has a container runtime installed and the kubelet is running on top of it, it's joining, and that's the only thing, as a developer perspective, I'm interested into it. So, and also in most cases from the operational side. So really having one tool to manage all of this, also in your bare metal environment. And like we already discussed with Fabian, like potentially if you want to run CI tools on cloud providers and you want to use bigger machines, this could be also a possibility. Running nested on cloud provider, or using like Packet running on their infrastructure. So then you can easily deploy this on their infrastructure with KubeVirt and having VMs. And then additional, you really have this benefit. If you need a dedicated VM, you can spin it up side by side, and they are on the same network. They can talk to each other. You don't must think about, okay, how do I now get my traffic from outside of my Kubernetes cluster inside my Kubernetes cluster? They could work on the same network, same storage, and all this kind of stuff. Yeah, as I said, these are the 2 main links, the KubeVirt repository and the machine controller. It's It's a POC, it's not polished yet, our setup, so you must do a make deploy. But in general, it's working. You can use Minikube, or there are also some Terraforms to spinning up a Kubernetes cluster, and you can connect this with a bare metal cluster, and then you easily can try this out, play around. If you want to have feedback, create a PR or contact us. We also have a booth there if you want to talk about this with us, really interesting about feedback. If you see a use case in your environment, we're really interested to see, okay, where this can go, because we think there is a lot of potential in this. Yeah, that's it. So we would now open it up for Q&A.
Test, okay. KubeVirt's very new. It's something that's being actively developed from last year up until now. So we're just getting to the part where we're starting to see people actually adopting it. We've seen, I think most of the interest that we've seen is people that have traditional workloads, they're running virtual machines that want to converge on top of Kubernetes because they want the ability to have that operational simplicity that I was talking about. As far as specifics go, I don't have any examples I can share right now. Yeah.
What's the underlying hypervisor that you're using?
It's KVM.
So
Richard.
realistically, like running traditional KVM workloads versus running them on top of Kubernetes, is it sort of a one-to-one? You can run some pretty beefy machines on KVM. Does the Kubernetes overhead add anything to that, or do you need to consider how big those machines are going to get?
So the question is, what kind of overhead does Kubernetes introduce for KVM? There's not a lot of overhead. So you have the Kubernetes components that are running on top of the bare metal, and we're launching virtual machines inside the container environment. And so you have things like C groups that are involved there, and just any sort of it's going to depend on how you've configured your cluster. And so the performance is going to depend on how fast your containerized environment is, so what kind of CNI plugin you're using and things like that. But from a CPU performance perspective, we're reusing what Kubernetes gives us. So Kubernetes has, if we're talking about like overcommit and things like that, that's some of the things people think about with virtual machines. We're reusing the same quality of service that Kubernetes provides us. If you have request limits and things like that, we are able to do like CPU pinning because Kubernetes provides us CPU pinning. So we're trying to leverage all the things Kubernetes gives us for performance. Yeah.
How are you implementing the live migration? Using something existing, or is it brand new, something y'all wrote from the ground up?
The question is how we're implementing live migration. We're using QEMU, so we're just tunneling it through the live migration features that QEMU already provide us. Right. Yeah.
For KubeVirt, is there any interest so far on like a PCI device pass-through?
Absolutely. So the questions about PCI pass-through, again, yeah, we're definitely interested in that. That's the same sort of thing where we need Kubernetes functionality for that. Let's go over here. Yeah.
So one of the reasons that we often would stay on a traditional VM might be for simplicity with regards to storage, local storage, and not yet having an integration with the Kubernetes or the newfangled distributed storage within a cluster. Does this require having the more newer Kubernetes integrated storage in order to run the VMs? How does that interplay with that?
Adam, do you want to answer that?
Yeah, I can. So basically, we work with any storage that's available in the cluster. So there is a local storage provider that Kubernetes will expose the local disk.
I don't know if I can carry it forward. I can? Okay.
Okay.
All right, yeah, so basically KubeVirt just uses all the native Kubernetes facilities. So any storage that's available to the cluster, whether it be host path or local storage, or statically provisioned persistent volumes, dynamic provisioning, CSI, any of the mechanisms that are available today would be compatible with this. So.
How much time do we have?
Good question. 20?
We have 20 minutes?
Oh, it's 11:20. I'm not sure.
I guess I'll just kick us off. Any more questions? Yeah.
Is multiple NICs supported through Multus or something?
Absolutely. So the question is, are multiple NICs supported through something like Multus? We support Multus specifically, actually. So yes. You're saying 5? Okay. Any more questions?
Yeah, there at the end.
Sure. So the question is KubeVirt compatible with service meshes such as Istio? We have lots of different networking options, and we have a specific networking option that plays nicely with Istio. And that's one of our use cases that we are definitely interested in. So yes, we do play nice with Istio. Yeah. The question is how to dynamically provision virtual machines. There's lots of ways of doing that. Cloud init, like you mentioned, we support that directly. So you can actually define your cloud init script in line in the virtual machine instance manifest. And you can also, we support, I believe, writing your cloud init into a Kubernetes secret. So if you have like a huge script, you can get like a megabyte worth of, I don't recommend that, but you can write like a megabyte worth of cloud init data there.
Yeah, this is like how we did it with the machine controller. So we generate, the machine controller is generating the cloud init file, and then the VM knows how to configure the container runtime and the kubelet and joining the cluster.
We done?
Further questions?
All right.
Yes.
So the reason behind KubeVirt is to have a unified management level for continuous virtual machines. Have you considered to go the other way, create a libvirt driver and manage everything via libvirt? Create a libvirt driver for continuous and manage everything.
So the question is, have we considered writing a libvirt runtime, like container runtime as equivalent, and have it where we launch virtual machines from like a centralized libvirt on the host? We considered that, but that removes some of the simplicity that I was talking about, where we just reuse everything that's already given us. We play nicely with all container runtimes, and that would prevent us from being a drop-in solution, which is what we're really going for. Question? KubeVirt support Windows. I'm assuming you're talking about Windows guests. Yeah, we definitely support Windows. That's an important use case to us. It's even part of our CI environment right now. More questions?
Perfect. So yeah, thanks for your time, and we will be here also available afterwards, or come to our booth. Loodse, it's close to the CNCF.